Hello guys, let's get right into it. So today we're going to have 3 objectives. The first is to understand Docker basics and get a clear overview of what Docker is and why it's useful. Second, we're going to master the essential commands that you'll use most often. And third, we're going to build and deploy a full stack app on Docker. So you're basically going to upload a CSV via React frontend, process it with FastAPI, and store it as a table in PostgreSQL, all in Docker. Docker is a tool that lets you package and run applications in isolated portable containers. These containers bundle everything the application needs to run, like code, libraries, and environment settings, so that it works seamlessly on any computer, eliminating the "it works on my machine" problem. Docker simplifies development, testing, and deployment by making applications easily shareable and scalable, while ensuring consistent environments across different systems. It's like creating a self-contained, ready-to-run app that anyone can execute without worrying about dependencies or system configuration. I have a construction analogy for 7 important Docker tools. So the first is that a Docker file is akin to a blueprint. A Docker file is like the initial blueprint for creating a specific environment. It contains all the instructions, code, dependencies, settings that define how the environment should be set up. Then we have the Docker image, which is akin to the construction plan. The Docker image is the final construction plan derived from the Docker file. It's a snapshot that includes everything needed to run the application, ready to be deployed or shared. And the Docker container, similar to the build structure, for example, your home. A Docker container is the actual live building created from the image. It's the running instance where the application operates, fully functional and isolated. And you can see the connection between these two, whereby when I have a construction plan, I can recreate the same structure in different places, similar to how the Docker image and the Docker container work. So when I have a Docker image, I can deploy several containers from the same image. Then we have the Docker Compose, which is like a project manager. So the Docker Compose coordinates and manages multiple containers, these point buildings, to ensure they work together smoothly, defining how each one should be configured and interact with others. It has all the services that you're going to need to run your application and interconnects them using networks, as you're going to see later. And the Docker volumes, akin to a storage. So Docker volumes act like material storage or utility rooms, providing persistent data storage. They hold essential information, ensuring that data remains intact even after the containers have stopped or are deleted. Then we have the Docker Hub, which is like the construction plan store. The Docker Hub is like an online store where pre-built images, the construction plans, are available. Developers can pull ready-to-use images or upload their own, making it easier to share and reuse images globally. Need a Postgres image, you can just pull it from the Docker Hub. Docker Cloud is like a remote construction site. Docker Cloud is the virtual space where containers are deployed and managed in the cloud. It's like setting up construction sites remotely, where you can manage your infrastructure and scale your application without worrying about physical hardware. This is my Docker cheat sheet, and it's going to show you most of the commands that you use consistently when working with Docker. The first thing that you're going to do is to build an image. The commands are docker build -t and then the name of the image that you want to create. So if you want, you name it whatever you want to name it, and then this period or full stop here. It's going to build an image using a Docker file that is located in the same folder. And as you remember, the Docker file is the blueprint that helps us come up with the construction plan. So it's going to use that to build the image. Then you can have docker build -t, the name and the tag, -f and the file name. So it builds an image using a Docker file that is in a different folder. So you just put here the path of the file, of the Docker file that is here. And then docker tag image name tag. So you're just going to tag an existing image to a specific tag. So the tag specifies the version number. Once you have that, you can go to the image. So for the images, you can see there are 6: Docker pool, and the image name. And by the way, make sure that you do not use the square brackets because this is just to emphasize what we expect in the command. So for example, if maybe your image name is my image, just say docker pull my image. No need to add these brackets. So this is going to pull an image from the registry. And then docker run the image name. It's going to run a container for that specific image name. And if it doesn't exist, it will be created. When you do this, it's just going to have a random name and port assigned. There are other key words or letters that you're going to need to contextualize your container, and I'm going to show you. And this docker run-d image name, it's just you running it in detached mode, meaning that you won't see all the processes taking place to start the container in your terminal. Then we have docker image inspect image name. You just get the image information. Docker system prune-a, it removes all images that are not in use by any container. And then docker images, it lists all the images. And as you're going to see, some of these commands are a bit similar and repetitive. So let's go to containers. For containers, you can see there are 7. Docker starts container name. It starts any container that has been stopped. Then docker ps, it lists all the running containers. Docker ps-a, it lists running and stopped containers. Docker stop container name, it stops the container but it will keep it in memory. Docker kill container name will kill the containers but will remove it from memory, which is not commonly used, but you can still know it. And you have docker rm container name. This removes a stopped container. You have to stop it before you use rm. And docker rm $, docker ps-a-q, it removes all stopped containers. And you can see the similarities, the rm, the ps-a, you can see it's being used thoroughly. So these commands are things that once you start using, it's going to stick slowly by slowly. So you don't have to actively memorize. Okay, you can actively memorize if you want. And then the volumes. The only difference here mainly is that you'll start everything with docker volume. So docker volume create, and then the name of the volume you want to create. Docker volume ls, it lists all the volumes. So here it's a bit different from ps for containers, running containers. Docker volume inspect, where you can see inspect is similar to what was there in the images. Display volume info. And then docker volume rm, again rm, to delete a volume, and docker volume prune, it deletes all volume that are not mounted. Once that's done, we can go to how to publish to Docker Hub and retrieve images from there. You have to know your username or registry name. Assume mine is jsiltech. Docker login -u, username -p password to log in. You have to be logged in to do this. And then docker tag my image, jsiltech / my image latest. So this is to tag my image and create an image that I can push to Docker Hub. So how to push it, you just need your username again and the image you want to tag, which is my image, and then the image, and you tag it with the version, so it can be latest. Then Docker push, so you push what you created here, this jsiltech / my image latest, that's what you push. And to pull it, to retrieve it from Docker Hub, use docker pull jsiltech my image latest. I'll have this downloaded and I'll share on my drive. So if you want it, you can access the image with these cheat sheets. Okay, so the first thing we'll need to do is to install Docker into our PCs. So Docker now has a pricing: personal, pro, Docker team, business. If you're like me, you'll just go for personal, get started, and then you'll install it for your operating system. You'll have to sign up and do all that. I already have it, but the process should not be that difficult. Once you install it, you can go to VS Code and check whether Docker has been installed in your PC. It comes with a good GUI, as you're going to see once you install it. You can sign in, so you can check it using Docker, and you can see if it shows you something similar to this, it means it has been installed successfully. To make your life easier, just install the Docker extension for VS Code. So just search for Docker. You have already installed it, so you just install it via Microsoft, and once you've done that, your sidebar, just click the icon. You'll be able to see your containers, your images, and your registries. But more importantly, you can use this tab over here to create your Docker files, Docker Compose files, and build your images. And it's going to make it easier to create a Docker file for the specific language you're using. For example, now if I wanted to create for backend, if it wasn't there already, we'll just come here and a greater than sign, exactly, add Docker files to workspace C. You just click it, select application platform. So you see, you choose what platform you're using, Python, Node, yeah, all this. Let's say I choose Python FastAPI. Once it loads, you can just choose the Docker files for your Python FastAPI, and you can use app.py. So you see, choose the app's entry point, manage.py if it was Django, app.py. So you can just say backend app.py. It will ask you for the ports, yeah, 8000. And then if you want to use the Docker Compose file, so you can say no, but in this point we will create the Docker Compose from scratch, so you can just say no. Yeah, I already have a Docker file. I do not want to create another one, and just go back. And to get that command, if it doesn't show up, you just say docker add and it's going to show up. Let me show you for Node how it works. You just use the package.json file, and then you'll select the port and whether to create a compose files. It's the same process. So let me start with the Docker files. The Docker files always begin with a from. It's the base image that you're going to use. So I normally try to use Alpine builds because they're normally smaller. They occupy less space compared to the normal base images that you'll receive. So from Node LTS-Alpine as build. Yeah, and it's going to be the same for every Docker file that you use. So you set up the working directory, workdir user as a C app. So here it tells Docker where the code is, where the code starts. And then we want to copy the package.json and package.lock.json files. One thing you have to understand is that in Docker, all these lines, imagine them as layers. Whenever you run a layer, if something changes, everything that is below that layer will change because it looks at every layer individually. If the layer doesn't change, it's just going to use the cache that it had for the initial build, ensuring that the builds will be way faster compared to if everything is arranged haphazardly. You can see we're putting it first into development mode. The environment is in development. And then we are installing the dependencies. So npm install, this is the main one, npm install, and then npm install -g-vit. For some reason, I had to install this because this is a vit app to run in Docker. And then cache clean -force, it removes npm cache for a cleaner image. And then it removes the root /.npm. I might not go into the details because I might also not understand the details that much, but I hope you can see why we are getting these fast before we go to this copy. And this copy this one copies the application source code. Every change that you make in the source code, because of this, it's going to rebuild that layer with a new source code. And that is why we want this part to come before this copy the application source code, so that you are not installing the dependencies every time you change your code. For example, if I just come to this source and tamper with something in app.tsx, that changes the code. If this copy application source code was maybe above the installation of the dependencies, since this changes often, we'll also be installing the dependencies often. And you know, npm takes a lot of time to install and it comes with a huge size. Pause. I hope you have a small understanding of what this happened. You can write it from scratch, but if you use the Docker extension to create the Docker file on VS Code, it's going to generate the initial Docker file and you can now work from that. Also, there's GPT, so don't, okay. Kill yourself if you want to, but personally, maybe I'm a lazy developer. I think I'm the bum developers nowadays, but if it saves me time, I will just go for it. Anyway, don't understand it so that you can now implement it with AI, or the other way, AI implements and then you understand whichever, but understand either way. And then now once we have all that information, we're going to build it for production, using npm run build. And you can see for we're using run here, run. And then from there, we're going to put it into production. So I normally use Nginx. I'll just pull it from Alpine as production. And you see we're also using the from here. So this is another stage. If this was one stage, this is another stage. And then we're going to copy the build outputs from this stage to Nginx default public directory. This I might not know exactly what it does, but I actually know what it does. You see, when you build your front end using React or npm, it creates a new dist folder, and in that dist folder, that's where your build is stored. It's just going to copy that. But yeah, it's just a folder, and it's going to store it to Nginx's default public directory. So you can see this part here, you user share Nginx HTML. This one I got from GPT AI, but it works, and it works really well, and I can share it with you guys so that you can reduce the size of your builds and images. And then we expose the port for Nginx, which is port 80. This is the port that you're going to use to access your front end in Docker. Docker's port will be port 80. The port it will expose, it's going to be port 80. And then how to start Nginx, you'd say cmd-g daemon off. This is like how you'd write maybe npm run dev. npm will be here, run, dev. You don't put npm run dev as one. So every word is in its own quotation. And to run it, you use cmd. You don't use run, because for some reason, when they were creating Docker, that was the idea. Don't try to change. Run is for these builds, but to start the server itself, you're just going to use cmd. So you can see here, this is the front-end Docker file, and it's way more optimized than my back-end Docker file, because I have not yet known how to, not known necessarily, but my optimizations are not the best for Python. For now, guys. But see, for Python, I'm using 3.12 Slim. I'll check for Alpine and see how small it is compared to this. That actually, let me just search and see. 312 Slim is larger than 312 Alpine. I think I'll just use Slim because of the compatibility. Also because I don't want to change something that is working right now. And then I set the environment variables. Don't write bytecode, Python and buffered. I'll need to go through what these ones individually do and understand them, or can go through them together. Yeah, if you haven't noticed, I use AI a lot. Yeah, so they're actually important. It optimizes Python performance. For example, this one, it prevents unnecessary file write, Python write bytecode. They make sense. It's just such a way to unbuffer. Just ensures that the logs are written immediately to console, so that you don't buffer them. The logs, you can see what's happening in real time. Pip no cache here. The caches of the packages are not stored once the images are created. So installed in the image, no need to cache them. That makes a lot of sense. Disable pip version check. Don't check for new versions during installation. Root user action suppresses the warnings about running pip as root inside the container. Yeah, so this one's just for preventing unnecessary warnings. We can continue. That was insightful. Workdir app, as we said. Oh yeah, sorry guys. I also had my explanation a bit warped. So the Workdir, it's not the directory in your PC. It's what will be created inside the image and the container, the app directory inside the container, if it doesn't exist, and everything will be executed inside that app by default to ensure consistency in path references. I'm also learning on the job, every dev job in the world. So we install the system dependencies, apt-get updates, and all these. Yeah, let's go through this one again. Copy requirements.txt to ensure that you have all the dependencies in your requirements.txt, because it becomes a hassle in Docker when there are several requirements are missing. and then install the dependencies in your requirements.txt, and then copy the code, the rest of the app basically. Then change ownership to an unroot user. You're creating an unroot user app user, and then the user will be app user. Let me check why we're doing this. So permission issues. So app user can read, write, and modify files. Makes sense. Running as root allows unrestricted access inside the container, basically minimizing the risk. And then finally expose the ports and start the application as we had said with CMD. Unicorn bind 8000. This one allows any hosts to join, provided it's with port 8000. Also make sure Unicorn, UVCon are all in your requirements.txt so that you don't have the issues of the requirements as I had said earlier. Yeah, so I think that's enough for the Docker file, but this part, install the system dependencies. Here is where we created an unroot user, add user disabled password. Yes, we don't need the password. And then we removed the lists. If for more context, let's just ask our able assistant. apt updates the package list from Debian's repos. So GCC compiles the Python packages containing C extensions. So this just refreshes the metadata. Installation without prompting. Yeah, no unnecessary packages. And then this one, it's creating a non-root user named app user. Yeah, I think we already said that. Don't log in with a password. Skips interactive prompts for user details. Geckos skip interactive prompts. This one cleans up the package list, reduce final image size. So actually it has been optimized. It has been optimized, guys. If you didn't have a good understanding of Docker files, I have used Docker severally before, but you can also see that I'm not that conversant with the Docker files. But the more repetitions you do, the better you get at it, the more you understand. Because right now, if you ask me, at least I know that this work is inside the container. At least I know that here we're just updating the dependencies for Debian, Python, and here we're installing the GCC libc-dev, which is basically the dependencies written in C. You have C extensions, compiling them. At least I have a grasp, at least I know something, and at least you also know something new. And then you expose the ports, and then you start the application. Once that is done, I think the next thing that you're going to do is I'll show you how to build the individual images for backend and frontend. As you had said, Docker build -t, you put the name, so maybe CSV, Postgres backend, and then the dots. Because, oh no, I can't put the dots because I haven't got into backend. So you get into backend and then you run this. I already had built it, so, and it takes time, so I won't rebuild it, but you can see it's quite straightforward. Yes, you just do the same for the front end, and it's going to create an image. Let me show you the one I had created before. I have several. Oh my god. Here you can see CSV, Postgres frontend and backend. You see the front end is a mere 48.32 MB. And the backend is 352.2 MB. The Docker site has a to-do app client and backend that you can pull from their Docker hub, and then you'll run it. You can see it's 1.18 GB and this one 1.17 GB. That's a lot, and it's all in Node, I think so. Yeah, but you can see the front end has really shrunk. Let me get into them so that you can see the layers. Oh yeah, and you can get the vulnerabilities here. Yeah, so you can see the Debian 74 MB. This pip install is what took a lot of space, but it installed the dependency, so it makes sense. So you can see the layers. You see, I told you every line is like a layer. You can see now each layer being created. You can go to the front end. Damn, this video is becoming longer than I expected, but I'm also learning on the job, you know. Yeah, you see the Alpine version was 7 MB for the front end. Yeah, so now once that's done, I'll show you how to run Postgres by pulling the Postgres image that is from the Docker hub. So now I'm going to show you how to create or run a container from Postgres. So it's going to be Docker run. We're pulling an image from Docker hub called Postgres. So it's going to be Docker run. First thing you're going to need is the name, -- name. You can call it whatever you want. Postgres DB. Then you're going to need the ports, -p, maybe 5433, 5432. So this is the container port. This is the port that will be exposed inside the container. This is the port that you're going to use to access this container on your PC. And then an environment variable, which is the password. Postgres password equals maybe pass. And then the volume. I'm going to create -v. I have a new volume, maybe I'll call it new vol, and then this colon, and then we're going to connect it to the Postgres data store in the container. So \var, \lib, /PostgreSQL, and then it's a / that is /data. And then -d in detached mode, then finally Postgres, the image name. So I won't run it because I've already ran it before, but basically this is how you run a container using the Postgres image. And you can create a volume using docker volume, create a new vol as we had already said in our cheat sheet. I can just do that to demonstrate. Docker volume, create new vol. I think first I can show you the list of volumes. Yeah, so you can see there's no new vol here. Volume name, blah, blah, blah. And let me create new vol. Let's run. Then to remove it, remember docker volume rm new vol. So I think you have a basic understanding of everything right now, and we can see how we're going to interconnect everything using our Docker Compose file. So when they're individual containers, yes, they can connect in a way, but it becomes very difficult because you'll have to create a network on its own to connect maybe the database to the backend. That network is easily created using a compose file, as you're going to see. So in our compose file, it's composed of services, and you can see I have the backend service, you can see run service, the front-end service, and the DB service. And then we have our networks. These are used to interconnect the different services, and the volumes. This is the volume I'll use to store data into the database. So let's start with the backend. The context is the backend. You can keep this folder over here and the Docker file. So if it was maybe in another folder, you'll just have said / which folder, then Docker file. The ports, whatever we exposed in a Docker file, so that will be the container port. And then this is our PC port, the port that we use to access that container with our PC. The environment variable is only the database URL that I had, and you can see it here. So you have to type it in because I'm using it in my DB. You can see URL os.getPNV database URL. Then the networks, public and private, I'll get back to that. And then it depends on the DB service and the condition. It has to be healthy. So this front-end, back-end, and DB, you can name them anyhow you want. So maybe you could even say F and B and DB, if that's how you understand. It's not much for them to be named that way. And then you restart. The restart is unless stopped. And then to the front end, the context the same, the Docker file the same. The port's port 80 as we had exposed it for Nginx, but I'll use 5173 because that's what I'm used to in Vite. And the network is public and it depends on the backend. Restart also unless stopped. Then we have our DB. Our DB, the image is Postgres. You see these other ones, I didn't use image because I'm creating the image by building it direct using the Docker file. But since the DB, I'm not building it, I'm pulling it from an image called Postgres. It's going to do that. Start always. The volumes you can remember, as you had said when writing the command to run the container, the Postgres DB, you put it CSV data vol, then var lib PostgreSQL data. The network is private. Remember the environment variable. So environment, we had only put in the password, but here you put in the user, which by default is normally Postgres, and then DB CSV DB. And then the ports 5432, which is what will be in the container, and 5433, which is just mine to prevent crashing with the actual Postgres in my PC. And this health check has to be there because if we put here service healthy, we need to actually have a health check. And this one, the username Postgres, so I had said here, the user, and CMD shell, it allows CMD commands to be run by this container with Postgres, and PG is ready. It checks if the database is accepting connections here. And then the interval, after how long will it run the health check, and then it times out after after 5 seconds, which is the health check is not responded to in 5 seconds. It assumes that Postgres is not working correctly, and then it will retry 5 times if it gets the timeout. Yeah, and the networks is just how we interconnect these services. So I have two, public and private. Again, the names don't matter. You can name them how you want. It's just that this makes more sense to me. Public in that I want the client to access them. So that's why the front end is in public, and the front end interconnects to the back end. And that's why back end is also in public. And then private, I do not want the client to see the whole DB. So that's why the DB is private. But since the DB also interconnects to the backend is also in the private network. And then finally, our volumes, the CSV data vol. With that, I think I can now try to run this. You run it by saying docker compose app, and you have to run it in the folder that your compose.yaml file is. If it doesn't exist, you'll just create and then write everything down. So let it start. Let me check my Docker. Nice. It's going to be named after the parent folder. So if it's CSV to Postgres, the container with all these containers. So it's going to run containers for all these services, and they'll be under the CSV to Postgres. So I come here at csv.postgres. Yes, and they're all running. So CSV to Postgres dash frontend 1 dash backend 1 dash db1. So now let's test it. So you remember what I had said, you upload your CSV file, and then once you upload it, it's going to be converted to a table, and that table is going to be stored in Postgres database. Choose your file. I'll choose Iris, upload the file. Nice. So you can see the existing tables, Iris 2025, February 26th, and then the time is because there are other Iris table names. So I had configured it such that if there's another one, it's going to add the time that it has been uploaded. And yeah, there's a 3-hour difference because I think it's using the UTC, the Greenwich Mean Time, run on the zeros. Is it longitude? Yeah, that one, the London time. And the Ghana, I know Accra uses that time, but you can see it's basically 3 hours ahead from my time zone. We can check whether or not the database has uploaded everything. I had tried to check it before. So you run docker exec-it, the name of the DB that you want to get into, then PSQL. If it was my SQL, I've said MySQL or something, and then dash is the username Postgres. And then you're going to connect with that Postgres that contain. So I can say, I can list all the DBs, /L. You can see CSV DB as we had created it. So the Postgres DB, we called it CSV DB here. So yeah, I can connect to CSV DB. Once I'm connected, I can list all the tables, /DT. Yeah, you can see there's another Iris here. I had uploaded it like this some few minutes ago, and then the new one. Let's select all from that table. Don't forget the semicolon. So you can say Setosa, Versicala, Virginica, and you're done. To exit that, you just say Q. I think maybe I can upload another one so that you can see. You choose another file, Nairobi data. Upload file. Nice, you can see Nairobi data is there. Let's check. Yeah, Nairobi data. Based on that, I hope you've got a good grasp of how Docker works, how to integrate a full stack application and run all of them using Docker. The more you practice Docker, the better you learn, and the more you internalize its commands. You've seen I'm also not that proficient with it, but I'm learning as I do. So as I publish to Docker, the more I understand. If you'd like to see how to interconnect a React frontend to a Django backend, here I used FastAPI, but another Python framework, Django, you can check out my video. It will come really handy. So have a great day, guys.